Welcome everyone to an Around the Block talk. So today we have with us Mr. Dr. Satya N. Gupta, and he's the chairman for Blockchain for Productivity Forum currently. And he's an industry veteran. He has spent over 40 years in the industry now, working in the capacity of chairman and a leader in various organizations. So, sir, I will hand it over to you, and we are very excited to hear what you have for us today.
Okay, thank you, Pratik. Good evening, everyone. It's indeed a great pleasure and honor to be invited for this talk around the blog on blockchain. So I'll be using my master PPT, which is meant for, of course, multiple purpose. It's a very lengthy deck. I'll be using only 1/3 of this in the beginning, basically to bring out the generic points about blockchain and basic concepts about blockchain and some use cases. So I'll not be going in much details in the time permitted, but if there will be some questions related to some of my slides which are there, I can bring them. But originally, I'll restrict myself to the 1/3, or let us say about 45 slides in the given time frame. So I hope that is okay with you. So now why it is again not working? It was working, but it has stopped working.
No, sir, it should be working. Like just click on the screen once and just try to,
okay. Let me say that.
And now try to.
Oh, yes, yeah, you are right.
Yes, sir.
It's
correct,
now working, yes. And this is the total content. And as I told, I'll be covering only 1/3 of that basic introduction to blockchain. Then the fundamentals of the underlying technology called DLT, distributed ledger technology, and how the blockchain works. What are the consensus protocols, building trust with blockchain, some latest developments and trend, and some use cases. So I'll not be going to blockchain 2.0 and then 3.0 in this initial talk. So again, I think it is. So okay, now I know I have to click on the screen, then on the keyboard. So what is blockchain? I believe this audience may already be knowing, and that is why they are in this class. Blockchain is a digital infrastructure, and this digital infrastructure name I have given from my side because I work in that domain. So where a distributed digital ledger is maintained by a network of computers or nodes. A network of computers is already known to us, and that is the internet. Internet is nothing but a network of networks, or network of computers, or network of nodes. So if you put a distributed digital ledger on the internet, then it becomes a digital infrastructure called blockchain. In this, information of a financial as well as non-financial transaction is shared with a decentralized network. This decentralized network means there is no central control. It is totally distributed and totally liberalized kind of thing, or autonomous, what we call, and validated by the entire network, because each node of the network plays a role, add value, add trust. That is what you'll know. Therefore, a blockchain infrastructure not being managed centrally, and that is the key here, not being managed centrally. That also means decentralized, effectively reduces the chances of data manipulation, failures, and leaves lesser scope for mishandling of the system by any single body. And that is the biggest thing about the blockchain, that it is not being managed centrally. There is no central controller here, which happens in most of the other kind of ecosystem, other kind of infrastructure, other kind of networks. It brings transparency, traceability, and trust. I call it 3T to the T, or you can call them 4T. It is all about transactions, and blockchain brings transparency, traceability, and trust. And how it does it? It does it through immutability and cryptography. cryptography is the key here in the blockchain, actually, though it is a digital distributed digital ledger technology, but its main ingredient or main you can say tool used here is the cryptography. So, and distributed ledger technology, which is the other name of the blockchain, uses the independent computer or autonomous computers referred to as nodes, you know that, to record, share, and synchronize transactions in their respective electronic ledger. Electronic ledger means digital ledger, not in the paper form, actually, instead of keeping data centralized as in a traditional ledger. So that is the difference. So it is not centralized and it is not traditional ledger, that bookkeeping kind of ledger. Blockchain organizes data into blocks. That is why it is called blockchain. And you will see what I mean by block, which are chained together in a append-only mode. So the data is organized in blocks, which are chained together. Chain means interlinked together. And an append-only mode, and that is another keyword used in blockchain. Append-only means what you call read-only, and you can write, but in a separate one. You cannot write in the same one. That is what is called append-only, and that is what brings immutability or indelibility to the blockchain. So a blockchain, as just to repeat, a continuously growing list of records called blocks. So a record is called a block, and that when more and more blocks are there, it becomes a blockchain, which are linked and secured using cryptography. Each block typically contains a cryptographic hash of the previous block. Actually, once you make a packet of information, packet of data, and it's a record or a transaction, and then it is converted in a block. After that, a hash is computed based on its content, like you know, checksum. In arithmetic, we use a checksum of any, you can say, digits. So that checksum here is hash. The hash is created for a previous block, and then it is used as an input to the next block. And that is how the interlinking will happen. So it is an open distributed ledger that can record transactions between two parties efficiently and in a verifiable and permanent way. Efficiently means because it is direct, what you call P2P. So there is no middleman in between. There is no central node, switch, router, nothing is there. So that becomes very, very efficient, because there is no middleman, and it is verifiable, and that is the characteristics of blockchain. And it is permanent because of the immutability, which you will see when we move further. So how does blockchain works? Just in a very, very permissive concept. As you have seen, it is all about transactions which are digital, which are recorded in blocks and then interlinked with the different blocks and making it a chain. And in a P2P form, the requested transaction is broadcast to a P2P network consisting of computers known as nodes, your normal internet, you can say. But it is P2P, there is no central controller. So the example shown here is a normal public internet at the lowest level, that is the infrastructure level, the physical infrastructure level. On base of that, you have the blockchain infrastructure, which is digital. So let us say someone requests a transaction. So he uses his node. Actually, from that node, he just input that transaction. It goes to everywhere else, whosoever is connected on the nodes. So then a validation happens. The network of nodes validates the transaction and the user status using known algorithm. There are algorithms, there are different programs, and that is what is the software used in the blockchain and different blockchain infrastructure, where the different mechanism of validation are used. And that is what. So a verified transaction can involve cryptocurrency. I mean, it can use cryptocurrency. Also, it can use contracts, records, or any other information. There are various methods of recording a transaction and various methods of validation. When we go in detail, you will know it. So a network of nodes validates the transaction and the user status using known algorithm, as I mentioned. So that is how, and once verified, the transaction is combined with other transactions to create a new block of data for the ledger. So that is how the chain starts happening. First, someone requests or someone put a transaction, others validate it, then they create. Even the validation also happens by a add-on transaction, because a transaction is append-only transaction. It cannot be altered. Only it can be added with one more transaction and interlinked by using hash. A new block is then added to the existing blockchain in a way that is permanent and unalterable or immutable. And that then only the transaction is completed. So that is how, in a very, you can say, primitive way, how the blockchain works. And the same thing is described here also in some more detail. Blockchain-based DLT, distributed ledger technology system, take the form of a append-only chain of data blocks. So you have to remember append only. It can be only appended. It cannot be altered or modified itself. Data blocks, and any record is a block, and record is the record of the transaction. New addition to the database are initiated by one of the members, and these nodes are called members, who creates a new block of data containing several transaction records. Information about the new data block is then shared across the entire network, containing encrypted data, so transaction details are not made public. They are actually made public in the sense the transaction or block itself, but its details are not made public unless it is a public blockchain. You will see there are different types of blockchain. So this is how the total chain happens. Now, there is one thing which comes very clearly here. Why we are talking of efficiency? The blockchain brings efficiency. That is the starting point. It brings so many things, but efficiency, transparency, trust, all these things. But efficiency is very simple to understand. So this is an example. Suppose we were using our conventional ledger system, that is also called paper-based process. On paper, like we write in the diary, like a bookkeeping clerk does it. So that is how, suppose it takes so much time, let us say about 10 dots kind of thing. And now you do digitalization. Digitization means you have made it digitized. Now you are using computer to keep that same record, same ledger. So you already achieve efficiency in that. So once an analog or a conventional process you digitized, so already you have saved about 30% of the time. So the efficiency is increased by 30% already just by digitalization. So that we are doing, everyone knows. But when you use further, you make it a distributed ledger. A distributed ledger means now there is no middleman. Now it is a peer-to-peer actually. Once you do that, then you achieve further about 10% more efficiency. So by using blockchain vis-a-vis the conventional paper-based process of record keeping, you can achieve about 40% or even 50%, 50 to 40% efficiency you can achieve by these two processes. One is digitalization and other is distribution, DLT. So both these things have to be used. So you can achieve 50%. So distributed ledger, what it does, reconciliation, consensus can be done through that. You will know that. Smart contracts, this is a great application of blockchain. Commercial value, escrow account kind of facility you can do without having a bank in between, without having a middleman in between. Then for security, we use cryptography. Otherwise, there are so many cumbersome ways of using security, but by cryptography, which is automatic. Cryptography is done by your node, by computer. You don't have to do anything actually. It is done by the software and you achieve the security without putting any your own efforts. And then immutability because it is append only, it cannot be modified. So it gives you the finality also. So these are the advantages of using blockchain. So now we go further. So some of the salient features I can explain, you would have understood by now. Blockchain is a digital ledger that stores transaction details, which are called blocks. These records are stored in containers. Actually, those containers are called blocks. These blocks are linked to each other and secured using cryptography. So these 2-3 processes you have to know. So after doing that, what happens? First of all, available for anyone to access, because when you're talking of a public blockchain, we will be concentrating ourselves to the public blockchain, that is the blockchain 1.0 kind of thing. So anybody have access. So the transparency comes. Data can be added but cannot be altered. That is called append only. So immutability comes through that. To add data, validators, miner have to verify the transaction. So there are two types of player here. One is those who actually initiated transaction or initiate a record or a block. And then there are validators or miners who have to verify the transaction. And that is what is adding value. It is getting verified by others. And that is how the trust comes, transparency comes. So, and the transaction has to be approved by majority in the network. That is the majority gain. Suppose there are 100 nodes in a particular chain, at least 51 have to validate that. Otherwise, it will not be accepted. And that is the proof or consensus, what you call it. No central authority has control over the information. And that is the key thing of the blockchain. It is a peer-to-peer or one-to-one kind of thing, or one-to-many, but no central authority. These are the key characteristics of blockchain. So there is no middleman, no central authority. That is where the efficiency comes. And privacy is protected by cryptography, by using pseudonymity kind of thing. So these are some of the salient features of the blockchain. Attributes of blockchain as DLT, because DLT, the distributed ledger technology, is the main underlying technology of the blockchain, DLT. Two core attributes of DLT-based infrastructures are ability to store, record, and exchange information in digital form across different self-interested. Self-interested means they are just working for themselves. They are not working for anybody, or their interest is, let us say, private or their own. Counterparties without the need for central record keeper. That is, again, I'm telling, no middleman is required, no central authority is required. It is peer-to-peer. And without the need for trust among counterparties. The other parties who are interacting with each other or who are transacting with each other need not to have any trust. That is also called zero trust. So zero trust, they don't know them, no trust, but still it will be done through data. The blockchain will bring the trust part actually. It is not the trust, you don't have to trust the other party. You have zero trust in the other party with whom you are doing transaction. But the data and used by blockchain will do the trust part actually. So you don't have to worry about the trust. It is automated here. And sure, there is no double spend. That is another thing which happens in ledger. The same money or same asset cannot be used twice or cannot be given to different, more than one actually. Same asset or token or money cannot be sent to the multiple party. And that is the double spend problem which is there in a conventional ledger system. So it is taken care of here. So the basic blocks of blockchain, now you would be knowing the starting point is DLT, of course, which stands for distributed ledger technology. That is the underlying technology. And blockchain, by now you would have understood, an immutable distributed database. So it's actually a database, but it is distributed and immutable, not a conventional database. That is a log of blocks which are interlinked through hashes and cryptographically encrypted and replicated on all the nodes. So it's a public blockchain we are talking now. Any information, any block is available to all other nodes connected to the blockchain. And block, as I mentioned, a digital container or a data packet for transactions, contracts, property titles, ownership, assets, records. It is a data packet. Everything is converted into digital information. And that is what is put in a digital container called block. And blocks are secured using public key encryption. So encryption is used here for securing those blocks. And that can be done through cryptography also. The code of each new block is built in that of the preceding block through hashing, and that is checksum. Each block, whatever is created, will have a checksum. The checksum is used by the subsequent block so that it gets interlinked with the previous one. It guarantees that it cannot be altered or tampered because checksum is used by somewhere else. And now if you alter a block, the checksum will not match, and hence the interlocking will not happen. Validation will not happen. The blockchain is viewed by all participants and nodes, as I mentioned. So it enables validating the entries in the blocks, and privacy is also there through pseudonymization. So your actual name is never reflected. So it is changed. So there is a privacy and there is a validation. So what makes blockchain ecosystem? So by now you would have understood, as I mentioned, blockchain is a digital ledger technology, but it has an ecosystem. What all the technology involves or contains. So one is the transaction. That is the starting point of blockchain. The first T of blockchain, transaction. It is all about transaction. Trade, everything, there is a transaction. When you actually interact with anybody, there is a transaction of information, transaction of thoughts, transaction of wealth, transaction of value. It is all about transactions. These blocks are the records of the transaction. Immutable blocks, as I mentioned, cannot be changed. They are append only. Decentralized peers. Decentralized peers mean peer-to-peer. They are not centrally controlled. Distributed computer network is our conventional internet. If I have a computer and I'm connected to the internet, so I'm part of a distributed computer network. So that is the existing infrastructure which is used by blockchain. That is the starting point of blockchain as far as infrastructure is concerned. Then encryption, cryptography, key distribution like public key distribution, private key distribution. These are the other tools used here. Consensus mechanism is very important thing, means how the trust is built in actually, how the truth is discovered and validated. Then smart contracts, actually, that is what is having a great promise of adding value. The smart contracts are a attribute of the blockchain called Ethereum, which can actually automate all our contracts or the agreements, concession agreements, and they can also add smartness to those contracts in the form that they are immutable also, they are trustworthy also, they are tamper-proof also. So everything happens instead of, in addition to digitalization and automation. So that is what is one of the very important application of blockchain, will be smart contracts. Then DFs. DFs stand for distributed apps. Actually, the apps itself will be distributed, and that is what is happening otherwise also. But blockchain makes it more easier. And then DAO is another part of the ecosystem. DAO stands for decentralized autonomous organization. Normally organizations are centralized. There is a central control. There is a board of controller or board of directors. So in blockchain, it is totally decentralized, totally autonomous. And then the blockchain cooperatives are there. That is also called blockchain consortium or entities. And that is another part of the ecosystem. So this is what I meant by your decentralized peers and distributed computer network. Normally our legacy network is centralized. There is a central controller, and that is what is called hub and spoke model. So there is a central hub, and then to that you are connected. That is, you connect to a switch actually, like in an office, your LAN is there. So LAN is not decentralized. It is localized, but there is a controller there, the LAN controller. Even if you are using Wi-Fi, there is a wireless LAN controller, WLC there. In your office, you have a switch. So that is the legacy network. But what blockchain uses is the distributed computer network actually. This is shown in this diagram also. Now, this immutability I mentioned, a very important feature of the blockchain. As with the existing databases, blockchain retains data via transactions. That is same thing happens on the normal databases, and same thing happens in the blockchain. It is all about transactions. The difference is that once written in the chain, the blocks are extremely difficult to change. You actually can never change them, requiring rework on all subsequent blocks because there is an interlinking hash of the previous block, which is the starting point of the second block, and consensus of each. The transaction recorded in a blockchain is therefore considered immutable or indelible. In other terms, blockchains are write and read only, that is append only. Like a ledger written in ink, an error would be resolved only with another entry. You cannot cut, like in the bank checks it is happening. A similar thing is achieved here actually. Then encryption and crypto, that is another tool actually, which brings a lot of advantages to the blockchain. You use standard encryption practices. Some blockchain allow your own, bring your own encryption, only as good as the next hardware innovation actually. So that is where your computer powers are used actually. All blocks are encrypted by using encryption or cryptography. Some blockchains are public and some are private. We'll be coming to that. Public blockchains are still encrypted, though they are public blockchain, but still encrypted in there. That means data is accessible to everyone, but everyone cannot really make out what it is because they need keys, and there can be keys, public key, private key. So by using that only, you have either you can write only, or you can view only, you can view few transactions only, or your own transaction, you can view all transactions. So different rights can be given actually to a user. And that is what is another, you can say, attribute of the blockchain. Now this consensus mechanism, most important thing in the blockchain is the consensus mechanism. That is what brings trust and validation and the truth to the blockchain, because there is a no middle party here, no central authority. So it has to happen through technology. The trust has to be built through technology. So ensure that next block in the blockchain is one and the only version of the truth. Keeps powerful adversaries from derailing the system and successfully forking the chain actually. So that is what consensus mechanism helps in that. And there are many consensus mechanisms, each have its advantage and disadvantage, but at least one of them is used. These are called proof of work, which was used in Bitcoin, proof of stake being used in Ethereum. Then there is proof of less time, proof of activity, proof of ownership, proof of capacity, proof of importance, benefit, welfare, impact. There are so many actually. This proof of impact, I'm working, it is still not there in any literature, you can say. So I'm working on a proof of impact related with the sustainable development goal. Some of the project I'm doing on that. So I want to use blockchain there, but I will not be using these conventional consensus mechanism. I'll be using the proof of impact, the impact it makes, how much impact it has made, what was the basically planned impact to be achieved, but what actually have to be happen, and that will be by using the survey from the end user. So end user will also be a party here, and they will prove whether it is true or not, whether it is successful or not. So that is called proof of impact, and there can be many. It is all evolving thing actually. And it is all about creating witnesses. So if you want to have transparency and trust, there have to be witness. If something is published on a blockchain, all participants become witnesses actually, because they have a copy of that block. And if it gets altered, they will come to know. And then next one will not interlink because of the hash getting changed. So it is used, there is an example, origin stamp, time stamp, all these, it is used there. And now this is just a diagram of just describing blockchain versus DLT versus DAG. A new kind of blockchain is coming called directed acyclic graph. So a distributed computer network, as I mentioned, is like a like your internet. Is a collection of autonomous computers, nodes. Each one is autonomous here, so it is not that way connected to any switch in between. That appears to its user as a single coherent or autonomous computer, like autonomous node. Then there is on top of that, there is this blockchain called distributed ledger technology, DLT, append only transactions stored on a distributed computer network. Computer network remains the same. You just store this blockchain infrastructure in the form of DLT. So a blockchain, a subset of the DLT, is a cryptographically secured chain of blocks. So DLT, that means distributed ledger technology, can use any form of encryption, not always cryptography. Like cryptography is ideally used for cryptocurrencies, this Bitcoin, all that. But blockchain does not mean it you have to use it for currencies only or money exchange or cash only. It has so many other applications. So there can be some application, you may not be even requiring to use cryptography. So it is not, you can say, the integral part of the blockchain. It can be done by other methods also. And then there is a directed acyclic graph. DAG is a mathematically interconnected structure that consists of vertices and directed edges that never form a directed cycle. In the case of DAG-based DLT, the vertices often represent transactions or blocks, and the edge represent parent-child references between the transaction or block. So you can have a blockchain kind of thing by this also without using cryptography. So this is another, you can say, evolution of the blockchain. And now the blockchain digital infrastructure, what is the main subject here? So this blockchain digital infrastructure, which was actually a blockchain ecosystem. So I want to name it as a digital infrastructure. The digital infrastructure, as you know, means a, let us say, virtual infrastructure, not anything physical actually. So what first, there is a distributed computer network, that is the underlying infrastructure where you have your computers connected to the internet, and they have their ASN number, autonomous number. And then on top of that, you run another layer called blockchain protocol, and that is your DLT part coming here. On top of that, instead of a operating system, you use what is called a virtual machine. The virtual machine is basically, they give the processing power of a machine, but without having your own processors. And then on top of that, you have these DApps or blockchain applications. So these are the 4 layers of the digital infrastructure. As you know, if you go to the OSI model of internet, there are 7 layers: physical layer, data link layer, then network layer, session layer, and you have these control layer, application layer. So those 7 layers are there. So here you have 4 layers actually. The main infrastructure in the form of distributed computer network, then blockchain infrastructure, and that is your DLT part, then virtual machine, that is the operating part, and then the apps. So that is how the blockchain digital infrastructure is separated, and this is how it is shown in the layers actually. So this is also called Internet of Value. Some of you would have heard that blockchain is also called internet of value. Like you had the public internet, which is there at the lowest level still. Then you got what is called a internet of things, IoT, which is in thing these days. And blockchain makes the internet as internet of value, because everything it does have relation to the value. Whatever it stores, it adds value. When one block is validated by others, the value is enhanced. When it is transmitted from one place to other, the value is enhanced. So that is what everywhere it is all about value. It is the storage and transaction of value. So this is the architecture. So at the lowest level, you have the hardware or infrastructure layer, which consists of virtual machine, containers, services, messaging, all that what you do. And on top of that, you have a data layer, and that is where the intelligence of blockchain comes, like digital signature, those key concept, hashing, Merkle tree, transactions, all that comes on layer of your hardware or physical infrastructure in the forms of your computer and your broadband connection. And then you have the network layer, and here network is peer-to-peer. So you just connect from one node to another node. There is no middleman in between. And then you have a consensus layer, and that is the main intelligence part of the blockchain. And you can have consensus, as I mentioned, proof of work, proof of stake, proof of these DPoS. Then there are different things, and I mentioned proof of ownership, proof of impact. You can make your own consensus layer actually. And then the app part comes actually, and that is what is the area of interest. Smart contracts is the most important app. Of course, if you go in the beginning, the first app was your Bitcoin, which have brought a lot of fame to the blockchain actually. And then the smart contracts are coming, and chain code, D apps, user interface. So these are the layers. 4 layers are the blockchain related layer, and 1 layer underlying infrastructure is the conventional internet connection or a net distributed network. So why blockchain? Actually, by now you would have understood why blockchain is becoming so important, so famous. Everyone wants to learn blockchain actually. Every day I get calls from totally unrelated people, not even technical, that I saw your lecture or I saw your post. What is this blockchain? I also want to learn. So that means it has become not only a hype, it has become a thing of future. Everyone wants to learn blockchain actually, because I call the blockchain has solution for everything. Solution for everything means I have called it a Ramban in India. You know what was the Ramban in Ramayana, and Ramban basically a panacea of everything. Whatever problem you have, the blockchain can actually solve it. Promises to solve. Of course, you have to know how to make use of the blockchain, but there is no problem which blockchain cannot solve. So if you want to reduce the cost, yes, it eliminates manual processes, reconciliation between multiple isolated ledger, administrative process. So cost reduction, I show you by those dots, 50% cost reduction is guaranteed actually. Increase speed because there is no middleman in between. So transactions and settlements through immediate distribution, no middleman. Then increase security, and the cryptography encryption brings the security. Reduced fraud actually. Blockchain, no fraud can happen because there is a transparency, time stamping, immutability. So no fraud can happen. Reduced risk also, because here there is no single points of failure, no single point of attack actually. It is distributed nodes. There are thousands of nodes. If 1 or 2 gets attacked, nothing happens actually, because you are talking of the majority voting here. 51% of the node has to be functioning so that you can validate a transaction. So all these problems of the conventional network, conventional way of working are taken care of by blockchain. The capability, some of them have become very clear, a shared ledger technology, allowing any participant in the business network to see system of control. That is the ledger. Ensures visibility, transaction are secure, authenticated, verifiable. All parties agree to the network verified transaction, that majority thing, business terms embedded in transaction database and executed with transaction. That is the smart contract part of it. And there are so many essential, actually, as I know, a business problem to be solved that cannot be solved with more mature technology. Blockchain can solve that. The identifiable business network with participants, sets, transaction, need for trust, actually. There is no need for trust here, actually. It comes through consensus, immutability, finability, or provenance. Of course, there are some negatives also. I'll not go for that. They are more for the theoretical purpose and for the bigger things. So trust building in blockchain, as I mentioned, immutability, transparency, and trust. How the trust is built here. So it is a distributed ledger shared by all participants, replicated everywhere, decentralized, append only, no update, no delete, distributed transaction validation. Validation also happen through consensus, unfalsifiable, it cannot be wrong, and it is verifiable. So that is what the trust building in blockchain, which was not there in any of your AI, ML, no trust is there actually. Always there is a doubt or gray area or some kind of issues are there. But blockchain brings the trust. Potential, actually, the increased trust in value exchange. Here they believe in trust the data, not the participants. You don't have to trust the participants. Like in bank, your KYC and all that, that is immaterial. It is the data actually, and that is what is required. Reliability, no single point of failure, increased security, tamper-proof, immutable, efficient, consistent transaction between participants, faster and cheaper than relying on a long chain of intermediary middlemen. Nobody is there. With incompatible systems, cumbersome rules, sometimes the system fails, a bank system fails, and no transaction is happening. Every day you see that if you visit a bank. Transparency, traceability, trust to the transaction. That is what I called 4T of blockchain. Benefits of blockchain are already, I think, clear. Transparency, decentralized, power to users, because there is no middleman. Each user have autonomous and all power. Quick transaction at low cost, no intermediary, and reliable database. That is, it cannot fail, it cannot be altered, it cannot be corrupted, it cannot be what you call hacked. All those protections are there here. This is about types of blockchain, but I will not go in detail because I want to just complete it. But public blockchain is open P2P network, private is the closed one. So you will have to wait. So there are public blockchain, private blockchain, and then there is a consortium. I have named that cooperative blockchain actually. Cooperative blockchain is a consortium of different members actually, controlled by a consortium of members, because single authority cannot be there as a controller. Then the blockchain definition is faulted. So, but it can be having a control, a cooperative nature of the consortium. Let us say each node is given the power to control, a distributed control. That is what. So that can happen actually. So there are different examples. You have already seen public blockchain, you know, Bitcoin, Ethereum, Dash, Factom. The private blockchains are multi-chain, Blockstack, there, and consortium, these Ripple, R3, Hyperledger actually as a consortium blockchain, which is a mixture of public and private. That is also making waves, but I'm not spending much time here actually on this. There are advantages and disadvantages depending upon the application. You have to use a particular type of blockchain. So we will not be spending much time here, because if you have to select the blockchain, it is very simple. I mean, if you need only one copy, no blockchain is required. A traditional ledger, you just digitize that. That itself will save 30% of the waste. If you have many, then who wants to own it? If there is a single owner, again, it has to be permission private shared ledger, like a bank chain. And If anyone can own it, that it becomes a public. Public also can be permissioned and unpermissioned. Now there are different assets. Actually, native asset means for using the blockchain, you have to spend some money, which should be a blockchain asset. So at the moment, two blockchain assets are there, either Bitcoin or Ether. Ether is also called gas. So first, you have to have that. You have to have a wallet. You have to buy these things for using a blockchain infrastructure of anybody. So that is the native asset. Native asset means a asset which will be accepted by the blockchain. And but there can be some free blockchain also, some public blockchain, some of them may be free. So either you use the free or you have to pay through the native asset actually. Blockchain history, I think you all know, but the lesser known part is it started in 1982. This is some titled computer system established, maintained, and trusted. But people forgot it. The actual blockchain became famous by that white paper written by Satoshi Nakamoto in 2008, who is trusted as a father of Bitcoin, actually. And that was the beginning. And now it is moving. It is moving. And in India, and I'll be stopping now, India, the national strategy on blockchain by METI, Ministry of Electronics and IT. So they have come out with a national blockchain framework. It is available on their website. This document covers various aspects such as vision, mission, objective, technology overview, spoke like what I've been talking, national, international scenario. It's a very comprehensive document available on the METI website actually, and that is our national blockchain framework. That means government is also working on that. A lot of public consultation stage outcomes for the 5 years. Huge cases, I'll not be spending much time, but there are so many actually, so many. Smart contract, digital currency, which record keeping securities, and then you can, through that you can manage digital rights, wagers, escrow account, equity, private debt, crowdfunding, everything blockchain can play a role. That is what this shows actually. So I think I've taken a lot of your time already, and now if there are some questions, we can take those instead of going further. Prateek.
Thank you very much for this informative and insightful talk. I would ask the audience if there's a question for the speaker.
It is a very
yes, it is a very good presentation, very informative. Thank you very much, Satya sir.
Thank you.
I have two questions. One is SWIFT protocol. Can it be replaced by blockchain? And secondly, Indian government is implementing, working on blockchain research and implementing. But are there any private companies also implementing blockchain in India? And if you know anything abroad, if you can let us know. Thank you.
Oh, yes, it's a very good question. As far as this, your first question was what was the first question? I've forgotten actually.
Yeah, it was SWIFT protocol. It is a protocol for payment.
The SWIFT protocol can easily be replaced, because what SWIFT protocol does is it works as a middleman or a mechanism in peer-to-peer, because here you become peer-to-peer, so no central controller is required. SWIFT is actually playing the part of a middleman. So middleman goes away here in any case. And what is the role of middleman? Middleman role is to put everything together and also to bring trust, because you will trust. Everyone trusts SWIFT actually. That is so rigid protocol. Every bank is using it. But that requirement is taken away by using the peer-to-peer communication and consensus mechanism, which brings the trust. So it is easily replaceable. About the government, as I mentioned, this METI thing, government is already doing, but more than government, private parties, lot of private blockchain initiatives are there actually. There is a India Blockchain Alliance all over the world, of course, so many things are there. You just Google the blockchain. Actually, it is full of the work given by full of all these currencies. What you are knowing, they are all blockchain application in the private sector. Government is yet to adopt the blockchain for the currency part. In India, also a lot of applications on the private sector, though government have taken the lead in asset management, land records like the certification, the NFT of certifications, and these TRA have come out with a telecom that do not call registry thing. But on the private sector, the famous blockchain applications you would have known, NFTs, non-fungible token, done by even this our Khan's brother Amitabh Bachchan, all these film thing. And you may be knowing Agama.com, Neeraj Roy. Neeraj Roy have put all the T series on the blockchain of Gulshan Kumar and all these music. That is the world's biggest NFT storage actually. So like that, a lot of people are working on blockchain in India and abroad in private sector also.
Thank you.
Any other question?
Yes, thank you, sir. Any other question?
Sir, hello, sir. It was a very insightful session. Thank you for that. So one question I would like to ask you is, so like you mentioned, Bitcoin, it was the white paper was released on 2008, and then it started in the year 2009. But why is it taking such a long time for for people to adopt this particular technology, since it's already there for the last 1 decade? So what is that one thing that you think that is stopping us to go this particular technology as a mainstream? Your viewpoint.
Oh, yeah, a good question actually, because this is a very new technology and some kind of, you can say, risky thing actually. It needs investment. It needs two things actually. It's not free, first of all. Blockchain, first of all, it needs the knowledge, skills which are not there. You need coders and all that. The second thing, you need to invest in the infrastructure, that blockchain layer. You have first layer, you already have. These are our computer connected to internet. The first layer is there, physical layer. Then the blockchain layer comes. The blockchain layer is a very complex software actually. Very complex software which everyone cannot have. So what is done is there are infrastructure being created, and earlier everything was happening on the finance side, like this currency side. So after 2008, a lot of work has happened actually. A lot of you can see now 2000, though 83, that guy, other professor mentioned about that, it did not click, but it clicked in 2008 with these Bitcoin. But after that also a lot of things are coming, but most of that actually is happening on the crypto side or fintech side, currency side. So that is what, so, and it is now Bitcoin is not the only one, Ethereum is not the only one. There are thousands of currency and the work is happening. So it has not stopped, it is growing also. But what we are talking now and our forum, Blockchain for Productivity, we are talking about the application of blockchain in the non-financial or non-currency thing actually. And that is what is a new thing which is happening. And that is where more and more work will happen. In that, NFT have already started actually, what I mentioned, non-fungible tokens actually. Non-fungible token. These are the new digital assets. So they are not actually currency related thing. You can put any assets on the blockchain and make it NFT in the form of a token, and its value will increase. You just put anything, convert it to NFTs. You have taken a rare photograph of a bird or some incident, just put it on the blockchain and convert it into the NFT. So you have already created value to your that photograph. And it is a proof of ownership. NFT is a proof of ownership. It also works as a escrow account. Otherwise, escrow account is to be opened in a bank, but NFT can be used as a token, just like a escrow account. So a lot of applications are now coming, but yes, you need one, knowledge, and second, the infrastructure. The infrastructure, creation of the infrastructure needs a lot of money, and it is also consuming a lot of power also. That is another negative of the blockchain which we are trying to solve. Actually, my proof of impact will be a green blockchain actually. all the proof of works or proof of ownership, proof of stake, all these are using so much energy actually. So the blockchain is getting a bad name. So instead of that, there are different mechanism of proof. So these are work in progress, but biggest stumbling block in the blockchain infrastructure, which needs a lot of money. So once you create that infrastructure, the other people can use it by pay as you use, by paying in those native coins or tokens. So these are some of the, you can say, stumbling block, but works have not stopped. It is happening. It is happening in big way actually. After Bitcoin, so many coins have come, as you know. And Ethereum also a lot of application. Now this land record, asset management, supply chain management, everywhere blockchain is being used. But yes, it is just a beginning. As I mentioned, blockchain can do whatever you want to do. I always call it a Ramban, or in some forum I called it Aladdin ka Chirag. It is actually, that is the potential of blockchain. A beginning has been made. It is just the beginning.
Thank you for your answer, sir. That was insightful.
Thank you.
I guess that's it from my side, sir.
May I ask one more question if there is time?
So,
oh yes, I think you please go
Sure,
ahead.
sure.
What is your name, madam? I forgot your name.
Sagarika
Okay.
Basak.
Oh, Sagarika Basak. Okay, please go ahead.
Yes, one question. How is this related to Web3? I'm reading about Web3, which is the next upcoming technology.
Oh yes, the Web3 is next upcoming. I'm working on that myself actually for last 1 week, and in May, actually on 13th, I will be conducting a seminar on Web3, though I'm still working. So it is, you know about metaverse. I think most of you would have known about the metaverse. It is the upgraded version of metaverse. So web 1 came in 1980, which was just an exchange of emails, and then web 2.0, where we are now, it came. So web 2.0 was basically more interactive, more content oriented, and it got hijacked by metaverse. The metaverse is a good thing, but only problem is it is monopolized by 5-6 big companies like Google's, Facebook's. So it is not distributed. It is not decentralized. So Web 3.0 will be a decentralized metaverse. So it will use blockchain for decentralization, so that your data, your content, you are the owner, you can do whatever you want to do. Now, what is happening in metaverse or Web 2.0 is, whatever is your content, it is monopolized by other people who are spending money on generating the content or creating the infrastructure. So that is the difference. So it is the future. It is not there yet. It will take, according to 5 more actually years. And that is what the future of blockchain. Web 3 is some of them. It will actually make use of blockchain, AI, IoT, and IPv6. I'm working in all these to bring Web 3 actually as a concept, but actually it will take a lot of time before you get Web 3.0. So it will be the convergence of blockchain, AI, IPv6, and IoT, and it will convert your metaverse into a distributed metaverse, which will be called Web 3.0. So it will be called decentralized autonomous internet of value. Decentralized and autonomous. The metaverse is not that.
Yes, I mean, that makes absolute sense, because when I was working with Vodafone, we were making sure all applications move to IPv6. So yes. I think there is a movement that, we need to have that. Otherwise, they will not be able to remain in the network. So we are doing that. So I guess this is all linking to that. So it's very interesting. Thank you very much, sir.
Thank you. Thank you for your questions. There are a lot of things. So you wait for our next seminar, which will happen on 13th of May, which is actually on Web 3.0. And we will be claiming it India's first webinar on Web 3.0. And all our webinars are free method. They are totally decentralized actually.
Perfect. It is what
So
we need.
you can visit our website also, blockchainforproductivity.in, where it will be announced.
So I think we can close the talk now. And thank you very much for your time and the insightful session. And
Thank you.
we at IDS and me personally also, we would like to keep in touch and continue the knowledge sharing.
Oh, sure. It
Thank
will
you.
be a pleasure and honor for me, Pratik, and thank you for giving me this opportunity. Thank you.